Hey, physics fan, we are doing vector beginnings worksheet, just going over adding vectors together and what that means. So this is a great way to just school yourself on, hey, am I understanding everything going on with vectors? So if we look at number one, the number one says the resultant vector when this vector and that vector are added together. Remember, when we add vectors, we always add them head to tail. So because of that, we'd organize it that way, and the resultant always starts from the beginning tail to the ending head. So that means that this answer would look like that. It would be B. The resultant would be at that angle. How about number two? You've got four vectors of the same magnitude are added together. One pointing east, one pointing west, one south, and one north. The magnitude of the resultant vector is, what would it be? Well, if you look, one east, one south, one west, one north, head to tail, add them all together, where do they end up? All in the same spot. So the resultant would end up being 0 for that one. All right, let's look at number 3. What is the resultant of two vectors acting at right angles to each other and having magnitudes of 6 and 8? All right, so if they're a right angle, let's say this one's 6, this one is 8, then we have to figure out the resultant, which is from the tail of the first one to the head of the second one. We have to figure out what that actually equals. And to do that, since we have two of the three sides, we can do a little Pythagorean theorem action. Since this is x and that's the hypotenuse, I know it's going to be a squared plus b squared equals c squared. So 6 squared plus 8 squared equals my c squared, or my x in this case, for my resultant. So I got 36 plus 64 equals x squared. If I put that in the old calculator, right, or just 36 plus 64, that's 100. 100 equals x squared. To get x all alone, I have to do the square root. And you know what the square root of 100 is? It's 10. So that's why my answer ends up being 10. Jumping to number 5, the resultant of the two vectors shown in the figure below. Now look at these guys are tail to tail. So let's actually set them up so that they're head to tail. So I'm going to do this one like that, and then the other vector like that. So what is the resultant vector going to look like? It's going to look like that. That's why A ends up being the answer. That's the resultant of those two vectors. Always got to add head to tail, even if they're not put together that way. Let's make them that way. Taking a look at number 6. Which of the following represents the y component of vector A shown in the figure below? Okay, so if this A is the resultant, that means we need a perfectly horizontal and a perfectly vertical. This would be my x and this would be my y component. They're asking for the y component, which means this one right here, which looks like that. So remember, anytime you have a vector on an angle, no matter what it is, even if it's going down like this, you can always break it apart into its x and y component. X is horizontal, y is vertical. So that's how we figure that one out. Good. I like this next one. It says, sketch the sum of the three vectors acting on the same point. Add them in two different orders. All right, we can do that. Let me start with my first one. There's my vector. Then it's going to go on an angle like this. And then the third one, horizontal like that. So my resultant would actually look like that. Okay, let's do it another way in a different order. I'm going to do it reverse. So I'm going to start with my third one, head to tail. Then I'm going to start with the next one straight up, and then the other one this way. But when you take a look what happens. The green arrow, the resultant looks the same. That's because whenever you add up vectors, doesn't matter what order you add them in, the resultant ends up being the same. So that's a good visual lesson for you. If you didn't know that, now you know. There we go. That was number 7. If we take a look at number 8, we have a problem here. We have a Chicago White Sox player hits the baseball due east, so straight east at 50 meters per second, and the ball encounters a wind that blows north at 5 meters per second. So what is the velocity of the baseball? Okay. So we're going 50 meters per second east. So that's my vector. But there is a northern wind blowing at 5 meters per second. So because those two velocities are working together, the resultant velocity really tells us the true velocity. So we can figure that out. And the way to do that is, of course, with the Pythagorean theorem. Since looks like a triangle, we already have our two sides of the triangle. We just need to find our hypotenuse. So let's do that. A squared plus B squared equals C squared. So 5 squared plus 50 squared equals C squared. 25 plus 2500 equals C squared. 25 plus 2500 is 2525, C squared. And let's take the square root to get C by itself. And that R value, right, that C is the hypotenuse. That's going to end up equaling about 50.25 meters per second. All right, now that we know that, that's great. It says don't forget about angle and direction. So we know the magnitude. This velocity is 50.25 meters per second. But don't forget, we have to find the angle, so theta. But I can do that. I'm just going to use my SOHCAHTOA. So I'm just going to choose sine. I'm going to do my sine of theta. Remember, theta is the angle right there. And sine, remember, is opposite over hypotenuse. So for me, from this angle theta, my opposite is 5. So I'm going to do 5. Divided by the hypotenuse, which we just solved for, is 50.25. Okay? When I do that, 5 divided by 50.25, I end up getting about 0.0995 equals the sine of theta. Don't forget, in order to get theta, we have to get rid of sine. To do that, we're going to use the inverse of sine. So I'm going to get rid of sine by doing sine to the negative 1 of 0.0995. So put that in your calculator. Sine to the negative 1, 0.0995. What I end up getting is about 5.71 degrees for my answer. Perfect. Now that I have that, now I'm ready to write out my answer. And I'm going to write it up on top a little bit because I'm running out of room. So my answer is, of course, the velocity, 5.25 meters per second. At, and this is where I say the direction and angle, 5.71 degrees. And take a look. The angle is coming. There's my east. There's my north. The angle is opening up north of the east line. So that's going to be north of east. So that ends up being my complete answer. Now, sorry, it's so messy. I ran out of room. But at least you can see now that we need to find the quantity. And we also need to find the direction and angle. Once you do that, you're using your trig functions and Pythagorean theorem. You now figured out how to solve for the resultant in a vector in an actual equation. So that baseball's flying at an angle that isn't exactly east, and it also isn't exactly 50 meters per second because the wind is helping it along as well. Pretty cool. All right, let's go on to the plane takes off 400 kilometers to the north, kilometers per hour to the north, and encounters a crosswind 30 kilometers per hour to the west. Okay, so here's my 400 kilometers per hour velocity to the north, and then to the west, I'll go to the left, is 30 kilometers per hour. We want to know what the resultant velocity of the plane is, which means I have to start from my tail and go to the ending head. I'm going to find my resultant, which also happens to be the hypotenuse of my triangle. So if I'm going to do that, I need to use my Pythagorean theorem again. A squared plus b squared equals c squared. Okay. I don't have my hypotenuse. Remember, hypotenuse is always your c value, and in this case, it's our resultant. So I'm going to do 30 squared plus 400 squared equals c squared. When I add those up and put them all together, I end up getting 160,900 equals my c squared. I know that I have to get my c or my resultant, whatever you want to say it is, alone. So I have to take the square root of that. And I end up getting my resultant as 401.12. So what does that mean? That means that my resultant is 401.12 kilometers per hour is what we think that airplane is traveling at. Now, perfect, except there's my magnitude or my amount, but I also need my direction. So I have to look for this angle, theta. Okay, no problem. Now that I have everything, I'm just going to go back to sine again. I know that my sine of theta, what I labeled, that angle, is always going to be opposite over hypotenuse. So my opposite is 30. My hypotenuse is going to be 401.12. I'm going to rock that out. I'm going to do 30 divided by 401.2. I'm going to move over the sign. So it's going to be sine to the -1. What's 30 divided by 401.12? It's 0.074779. Okay. Put that in my calculator. And what it ends up getting at is 4.29 degrees. Perfect. Now, we can put this all together. I'm going to throw it up on top because I ran out of room. But that means my resultant is 401.12. I can say the resultant if I want. And it's at 4.29 degrees. But what? It's going to be going west of the north line. So it's going to be west of north. Remember, if you ever get confused, just end with the word line. West of the north line, meaning the north up and down line. What that is, you got my final resultant here. That plane is traveling a little bit different speed than it started off as because the wind is impacting it and it's going on an angle as well. Now that we've done 8 and 9, I want you to try 10 on your own using the skills you have from 8 and 9 and your knowledge of vectors. Great job, Chem fam. Take care and see you all later.